electrical systems. We have seen in the previous cases mechanical translation system and mechanical rotational system. So here in the electrical system we are having three parameters: resistor represented with R, inductor represented with L, and capacitor represented with C. So coming to the sources in the electrical system, we are having two types of inputs. First one is voltage source and second one is current source. To understand the electrical systems, we need to know the following parameters such as voltage across an element and current flowing through that particular element. So in the resistor can be represented with the symbol R, and current flowing through this resistor is I of t, and voltage across the resistor is V of t. So therefore voltage across the resistor can be written as per the Ohm's law, R into I of t, and similarly current flowing through the resistor can be calculated as 1 by R into V of t. So coming to the inductor represented with L, current flowing through the inductor is I of t, and voltage across the inductor is V of t. So here voltage across the inductor can be written as V of t is equal to L into di of t by dt, and I of t can be written as 1 by L into integration of V of t dt. And coming to the capacitor, this is I of t, current flowing through the capacitor, and this is V of t, voltage across the capacitor. Then it can be written as V of t is equal to 1 by C integration of I of t dt, and I of t can be written as C into dV of t by dt. So here by using these electrical circuits we can find out the transfer functions. Let us take a circuit to find out the transfer function. This is a 2 resistor circuit connected in as shown in this figure. This is Vi input and this is V output, and resistor R1 and resistor R2. We know the definition of a transfer function, that transfer function is nothing but Laplace transform of output by Laplace transform of input can be called as a transfer function. So from this figure, what is the transfer function of this particular circuit means V naught of S by Vi of S. This is the output and this is the input. So from this circuit, output of the circuit can be written as voltage across the resistor R2. So from the voltage division principle, this can be written as R2 by R1 plus R2. That means generally voltage division circuit, voltage division rule is V naught of S is equal to total applied voltage Vi of S into voltage across that particular resistor divided by total resistor. So from this formula has been derived. So transfer function can be written as Laplace transform of output by Laplace transform of input, which can be written as R2 by R1 plus R2. So this is the way to find out the transfer function for an electrical systems. So we will take another circuit here. In place of resistor, I will take capacitor now. How can we calculate the transfer function means as shown in this. So this is Vi input, same I am taking, and this is R1, this is C1, output across the capacitor V0. So to find out the transfer function, V0 of S by Vi of S. this can be written as same voltage division principle. So I am calculating voltage across the capacitor, that can be written as total voltage Vi of S into 1 by C1 of S divided by R1 plus 1 by C1 into S, total impedance. So by simplifying this, we will get the transfer function like 1 by C1 of S divided by R1 into C1 of S plus 1 C1 of S. This will be cancelled out and the remaining will be 1 by 1 plus S into RC. Now this can be simplified as V naught of S by Vi of S can be written as 1 by 1 plus S into RC, where RC is the time constant of this RC circuit. So this can be written as 1 by 1 plus S into tau. This is the transfer function of this RC circuit, 1 by 1 plus ST. So one memory element is existing here. So now this is the first order system. In the previous case, only two resistors are there. There is no memory elements present. Therefore, there is no order of the system. So here one memory element is present, capacitor. Therefore, it became a first order system. Similarly, we will see if there are two memory elements. Memory storage elements like is nothing but inductor and capacitor. So if I consider two memory elements such as resistor is not a memory element. So I have considered memory elements like L and C. So this is the input Vi of S and this is the output V naught of S. So this is not V naught of S. Input is Vi and output is V naught. So for this we need to find out the transfer function. So therefore transfer function is nothing but V naught of S by Vi of S. So same we can calculate this one by applying mesh analysis. Vi of S is equal to I of S, current flowing through this loop, into R plus S into L plus 1 by C into S. So here this can be written as Vi of S is equal to I of S into R into CS plus S square into LC plus 1 divided by CS. Here V naught of S can be total voltage Vi of S into 1 by CS divided by R plus SL plus 1 by CS. So transfer function can be written as V naught of S by Vi of S is equal to 1 by 1 plus RCS plus S square LC. So this can be written as V naught of S by Vi of S is equal to 1 by S square into LC plus RC into S plus 1. So this is a second order system. Transfer function of this RLC circuit is a second order system.